All right, good afternoon, everybody. My name is Matt Roloffs. I'm the chair of the economics department here at Western Washington University, and I want to welcome you today on behalf of the department and the entire College of Business and Economics to today's special lecture celebrating the 50th anniversary of the College of Business and Economics here at Western. We're so fortunate to have Dr. David Reiley with us today, and we'll get to his talk here in just a moment or two. I'd like to begin, though, by reading our tribal lands acknowledgement and acknowledge that we gather today on the ancestral homelands of the Coast Salish peoples who have lived in the Salish Sea Basin throughout the San Juan Islands and the North Cascades watershed from time immemorial. Please join me in expressing our deepest respect and gratitude for our indigenous neighbors, the Lummi Nation and Nooksack tribe, for their enduring care and protection of our shared land and waterways. Now, a couple organizational details before we get started. During today's lecture, Dr. Reiley has agreed to answer questions as we go. We'll also use any time that we have left at the end for a short Q&A. If you're joining us via the webinar, my colleague Jason Query here is going to be monitoring the chat in the webinar feature, and we'll pass your questions along to David. And for those of you here in the room, we're going to keep the refreshment table set up outside after the lecture for a little while if you want to continue the conversation out there. Now, before I bring David to the stage, I'd like to say a few words about the 50th anniversary of CBE here at Western. In these comments, I need to acknowledge that I'm drawing on materials that were written, collected, and curated by the late Dr. Irwin S. Mayer, one of the founding faculty members of the college, emeritus professor and former department chair, Dr. David Nelson, and our department manager, Diane Brierley, who's kept all these records in great shape. So I was able to dig through quite a few old photographs and old stories about the college, and I'm going to share a few, not the photographs, but the comments at least, with you here. So the College of Business and Economics 50th anniversary, so you can do the math, was founded in 1976. It was a pivotal time for Western, a pivotal time for the world economy. Western was originally founded in the late 1800s as a normal school and offered its first bachelor's degrees in education starting in the 1930s. In the years that followed World War II, Western expanded beyond its original mission as a teacher's college and began developing programs across the academic spectrum, including subjects such as economics, accounting, and business. Those subjects, along with history, sociology, and government, were originally gathered in the Department of Social Studies in the mid-1950s. The first Bachelor of Arts for a subject outside of education was offered in 1947, and by the 1960s, continued growth led to the creation of a standalone Department of Economics and Business. This allowed faculty leaders such as Irwin Mayer and Howard Mitchell to expand their course offerings, establish the first distinct major in economics at Western, and integrate economics into the general university curriculum. This steady institutional development unfolded alongside major transformations in the global economy. By the time the college was formed in 1976, the Bretton Woods system had collapsed. Oil shocks from the early 70s had led to persistent inflation and unemployment, and ongoing debates over economic growth all underscored the central importance of economics in understanding and responding to a rapidly changing world. As the featured department for the January and February months of this anniversary year, our department's excited to celebrate our role in this story. Economics formed the analytical backbone of the college during its creation, shaping curriculum, informing research, and training students to think critically about markets, institutions, and public policy. Today, economics remains just as essential to the mission of the college and university as our students and the world at large confront new challenges, from globalization and technological change to inequality, sustainability, and shifting demographics. By grounding the college's future in rigorous economic thinking, the department aims to connect Western's history to its next 50 years. Now, for today's lecture, I'm very pleased to introduce Dr. David Reiley. David is an adjunct professor of information at the University of California at Berkeley, where he developed an online course on experiments and causal inference for the master's degree program in data science. David's a pioneer in the use of field experiments in economics. Economics has historically been an observational rather than an experimental science, but David's been a leader in the movement to introduce experiments wherever possible. He designed field experiments to test theories of auction bidding and charitable fundraising before he began to focus on experimental measurement of the effects of advertising on consumer behavior. David was a distinguished scientist in advertising and marketing science at Pandora from 2015 to 2025. Prior to that, David spent 2 years at Google and 5 years at Yahoo Research. At Yahoo, he earned the Superstar Award, the highest honor bestowed on a Yahoo employee, and he was previously the Arizona Public Service Professor of Economics at the University of Arizona, and has also taught at Vanderbilt University and the Kellogg School of Management at Northwestern. In addition to his leadership in the area of field experiments, David also achieved recognition as the first academic expert on the economics of online auctions, which is a subject that's near and dear to my own heart. He's also pursued microeconomic research on other subjects, such as the effect of bus driver incentives in Santiago, the strategic play of professional soccer and poker players, and the economics of email spam. David has served as the co-editor for field experiments at Economic Inquiry, as the vice president of information for the Economic Science Association, and one of his proudest achievements is leading a successful movement to restore the Pennsylvania Governor's School for the Sciences summer program with private donations after it lost state support in 2009. He holds a bachelor's degree in astrophysical sciences from Princeton University and a PhD in economics from MIT. David's talk today is entitled Experiment, Distinguishing Between Correlation and Causality. Please join me in welcoming David to Western. We'll take just a moment for the handoff.
There was a little buzzing going on when you were speaking. It seemed like maybe we were overdriving the speakers. Is there anything we should try with that?
Give it a go and see what happens.
All right. Am I buzzing? Am I amplified at all? I am. Okay, great. Let's take this. So, I have, I'm going to give this talk in 3 parts. I'm going to start with some childhood stories that are going to illustrate the way I think about correlation and causality. And then I'm going to talk about my favorite experiment that I did while at Yahoo, and then I'm going to talk about my favorite experiment I did while at Pandora. Just let's see, how does this work? No, why don't I stay here? No, that's also not working. What is wrong with my slideshow? Okay, that's good. How do I go back? Ah, excellent. Okay, so the first time I can remember, oh, thank you. First time I can remember consciously thinking like a scientist dates back to when I was 8 years old. And you might think from this photo that I would have been destined one day to be a fashion mogul, but no, it was science for me. That year I discovered Major League Baseball on television. I quickly became hooked. Oops. So when we get rid of the bar, then I can no longer advance my slides. That's interesting. What needs to be done? Can I put this somewhere else? I'll leave it down here. I don't think it'll be too much in the way. And if it gets to be a problem, somebody has an idea for how to resolve that technical situation, we can do that. I'm still not advancing my slides. How is Zoom interfering with my ability to advance slides? Okay, now I can do it again. I discovered Major League Baseball on television that year. I quickly became hooked. I listened to over 100 Pittsburgh Pirates games on the radio that season. And one day, I got my dad to drive me 2 hours into Pittsburgh so we watch a game in person at the River Stadium. It was awesome. And the Pirates won the game. 1978, same thing happened. I again listened to over 100 Pirates games on the radio. And my mom took this photo of me after I'd fallen asleep listening to the radio one night. Again, I got to go to one game with my dad. And again, the Pirates won. 1979, same deal. I got to go to one game in person with my father, get to see my hero, Willie Stargell, who's the captain of the team. And once again, the Pirates won. And I started thinking to myself, every time I'm in the ballpark, the Pirates win the game. And that year, the Pirates made it to the World Series. And my dad managed to score us tickets to go to a World Series game in person so I could do a high-stakes experimental test of my theory. And the Pirates won. So I became convinced that I was the Pirates' good luck charm. As long as I was in the stadium, they couldn't lose. Unfortunately, my best friend Ray had had the exact opposite experience. Every time he'd gone to the ballpark, the Pirates had lost. And so we made the fateful decision to go to a game together. And the Pirates lost 15-1 to the Montreal Expos. Now, some kids might have taken from this theory that, well, David's good luck charm was just no match for Ray's superior bad luck charm. But I, as a budding 10-year-old scientist, took this as evidence that my theory was wrong. And when I reflected on it, it hadn't been a particularly good theory from the outset. I mean, what mechanism could possibly allow my presence in the ballpark to cause the Pirates to win games? Was there some magical energy emanating from my body, infusing the muscles of the players so that they would play just enough better to win the game? It was clearly nonsense, and yet I had really believed it. This is my first lesson in humility. I realized I hadn't been skeptical enough of my own beliefs, and this got me wondering what else I might be wrong about. Now, I didn't cause myself too much pain with my erroneous belief that I could make the Pirates win games. I mean, it didn't even prevent me getting Willie Stargell's autograph. But I have caused myself and those I love a great deal of pain with other erroneous beliefs I've held in my life. So, to avoid being stuck in false beliefs, I have filled my life with experiments, not in a laboratory, but in the real world. And for my job, at least until SiriusXM accelerated my retirement with a layoff last year, I have been, for the last 18 years, conducting experiments received by millions of consumers every single day so that I could learn more about how advertising affects human behavior. And I've been doing these kinds of experiments for more than 25 years, first when I was a full-time professor and then when I became an industry research scientist. But for even longer than that, I'm doing experiments on myself in order to better understand the world and how I want to behave in it. So at this point, you may be wondering whether you're human subjects in an experiment that I'm running right now. If so, well, this joke is not going to work quite as well as usual. If so, I've got good news and bad news. The bad news is, yes, you are. And I didn't even pay you for participation as research subjects. But the good news is, you weren't here for the other version of this talk, where I just stand here in silence for 90 minutes for the control group. I want to take you back right now to 1986. This was the year of the Chernobyl disaster, the Challenger disaster, and the original Legend of Zelda 8-bit video game. I was 17 years old that year, and I believed each of the following things. You can look at the list if you like. This is drawn from a theater show that I've developed. It's autobiographical. And so I'm not going to get into all of this. But I will say that I no longer believe. So what I would usually do is give people an exercise to try to predict which of these beliefs I still hold and which ones I've changed my mind about. But since I want to get to the academic stuff, I'm going to skip over that for now. But the reason I'm putting it up is that I want to say I no longer believe that President Reagan was going to die in office, because he didn't. But as a well-read 17-year-old, I knew the following evidence. In 1840, we elected William Henry Harrison president. He caught pneumonia at his own inauguration, died in office. 20 years later, 1860, we elected Abraham Lincoln, assassinated. 1880, James Garfield, assassinated. 1900, William McKinley, assassinated. 1920, Warren Harding died of a heart attack in office. 1940, Franklin Roosevelt died of a cerebral hemorrhage in office. 1960, John Kennedy, assassinated. So in 1980, after 7 dead presidents in a row like clockwork once every 20 years, and we elected the oldest person ever to be elected president at that point in time, I was sure he was going to die in office. Not 100% sure after that business with the Pirates, but like 90% sure. And yet that theory was wrong too. The Ronald Reagan experiment invalidated it. Thank goodness I have developed the humility to admit when I'm wrong, lest people think me a lunatic for insisting that I have an ironclad theory that President Reagan must in fact have died in office. And what I've learned from both the Pirates and the presidents is that I can be very wrong in my beliefs. And often my beliefs have been wrong because I confused correlation with causation. In other words, often it looked to me like one thing causes another, but actually it's a mere coincidence. If I haven't collected enough of the right kind of data, then the two things, like my presence in the ballpark and the Pirates winning, might not turn out to be causally related after all. So how do we improve the accuracy of our beliefs? Well, I find that the 3 key skills or to be able to experiment with new ideas and new behaviors, be able to change our minds, and to be able to admit that we're wrong, especially if we have been wrong for a very long time. So one place that I want, oh, you're right, I want to take you right back to 1986, because as Matt alluded in my introduction, the summer before my senior year of high school, I got accepted to this 5-week summer program at Carnegie Mellon University called Pennsylvania Governor's School for the Sciences. And there, along with 89 of my fellow nerds, I got to have the intellectual excitement of studying Einstein's theory of special relativity and playing in a laboratory with lasers and spectroscopes. It's amazing. This was the place where I first fell in love with the idea of generating my own data in order to better understand how the world really works. But I went on to get a PhD from MIT, and this notion of generating my own data was still in my head from having gone to the governor's school. And then in the fall of 1992, when I was a second-year graduate student, I got asked by my favorite professor to be a research assistant. And I was going to get to work on the research question, does advertising really work? Now, folks generally assume that advertising must work or companies wouldn't spend so many billions of dollars on it, but what I wanted to know was what direct evidence could I find that would help me measure how much more people purchased because of the advertising than they would have purchased if there hadn't been any advertising. And my professor had negotiated access to a unique data set that no other economist had access to, so I was super excited. And I accepted, I was super excited because it's going to be this cool topic for my dissertation was going to be the basis for my career as a professor. So I accepted my mission to go down into the bowels of the basement library of Merck Pharmaceuticals in King of Prussia, Pennsylvania. And there I had access to huge tomes of data in exactly the shape of what we once called phone books, where I got to find out for every prescription drug sold in America, how many units were sold by the pharmaceutical companies to drugstores, and for how much revenue, May of 1983, June of 1983. And I also got to find out for each month how many pages of medical journal advertising were done for each drug, and how many minutes were spent talking by sales representatives to doctors about each prescription drug in America. And so on repeated trips to Philadelphia, I filled my suitcase with pages that I photocopied out of these volumes, because my professor had only negotiated physical access, not electronic access to these things, and brought them back to MIT, where I supervised undergraduate students typing all these numbers into spreadsheets. And then I plotted all of the data that they had typed in, found all of their egregious typos, corrected a bunch of other mistakes, found other weirdnesses with the data that had to be addressed, aggregated all the data up to the right level for analysis, and in the end, I concluded that these data could not answer any of the questions I was interested in. I had wasted 2 years of my life, which was depressing, to say the least, but even more depressing was to realize that more than half the articles published in reputable economics journals had exactly the same problem that I was worried about in my own research. So what went wrong? Well, sure, go ahead.
Were you not able to answer with the data, or did you not get the answer you want?
I did not see any way to believe the answers that I was able to obtain from my regressions. And so my professor and I were studying the anti-ulcer drug market that launched in 1977, the H2 antagonist market, but I've decided to update the example to make it a little more modern and relevant. So let's say instead that I was studying the market started by Ozempic in 2021. So Ozempic was the first GLP-1 agonist, and in fact, I've been on a GLP-1 agonist for the last couple of years, managed to lose 30 pounds. They're pretty amazing in the way that they can reduce appetite and enable weight loss in addition to treating diabetes. And so, of course, sales of GLP-1 agonists have gone up steadily over time, just like this graph illustrates. And my professor and I said, well, gosh, we have this wonderful opportunity to study a market from its very inception. This is terrific. And so we thought, well, clearly, the amount of advertising done this month is not all that affects this month's sales. The history of advertising probably also matters, right? So we decided to construct the stock of all the advertising that had ever been done. And we actually did it as a discounted stock, but I'm going to abstract from that for a minute, because the main thing that was going on was that every month we added to the total how much advertising got done in the next month. So this, of course, by construction must increase over time. We're never subtracting. In principle, that we could have estimated a discount rate that was high enough that it would have gone down, but that's not what happened. Because we took these two data series, sales, advertising, both are going up, feed it to the computer statistics package. It computes a positive coefficient to show that these things are correlated over time. We said, aha, this tells us for every unit of advertising done, how many additional units of drug sales did they get? And then I realized it tells us no such thing. We have no idea whether the advertising was cut. We're like assuming that all of the increase in the advertising had to do with the increase in the stock of advertising, but it could have had to do with other things. In particular, folks talk about GLP-1 agonists to each other, and they say, gosh, I lost so much weight, it's amazing. So the friends go and ask their doctors if they can have a prescription too. That word of mouth is an entirely separate mechanism from the advertising, and that I have no way to distinguish them. How do I know how much of the increase is due to the advertising and how much is due to word of mouth? And maybe there's a bunch of other reasons that sales have gone up or down over time. So I also want to point out one of my favorite pieces of chart porn from tylervegan.com. He loves to find things that are correlated with each other. And here we see that the number of people who drowned by falling into a pool, the red curve, is very highly correlated over this time period with the number of films that Nicolas Cage appeared in. And so you might worry that every time Nicolas Cage accepts a new movie project, he's causing people to die in swimming pools, right? Now, of course, I happen to know this correlation doesn't hold up in other years besides these, but if you zoom in on these years, it looks pretty convincing. So I talked about the word of mouth with Ozempic and the advertising that is also being done, and we can't distinguish with observational data about what actually happened. There is a lot we don't know. What if the company had advertised half as much? We have no idea. What if they advertised twice as much as they actually did? What if they had done zero advertising? We can't observe any of these counterfactuals. If we could, then we would certainly know advertising's causal effects, but we don't get to observe that in the real world data. And we really shouldn't be able to claim from these observational data that we know how much additional sales are caused by advertising. If the company really wanted to measure the effectiveness of their advertising, they'd need to think in advance about how do they want to run their ad campaign, and they could deliberately give different amounts of advertising to different consumers. Then we would know something, right? Just like they do when they test the drug in the first place to see whether it's efficacious and whether it gives side effects. You do a randomized controlled trial. Well, we could do the same thing with advertising, but folks weren't doing it. Without the deliberate experiment, it's really hard to be sure about causal effects. So I talked about how depressed I was, realizing that so many articles published in economics, even in the good journals, had this problem. They were purporting to show that one thing caused another, but the data they had really couldn't prove what their assertions were, and these articles were bunk. And, you know, people were making the same mistake that I made when I thought I could make the Pirates win games. Of course, that was when I was 10. Full professors of economics were still struggling with the same fundamental problem of causal inference. And so I've developed this course at UC Berkeley on experiments in causal inference. And there I really like to give people the exercise of looking at an observational study and telling a different story for what might be going on with the data. So I want to give you folks this exercise right now. Here's an example article I really like to share with people. Some doctors at the University of Montreal got some very personal data on their male patients, and they concluded that men who had sex with more than 20 female partners had much lower rates of prostate cancer than men who had fewer than 20 partners. And they actually suggested in the article that it would be a really good idea for men to have more sexual partners because it would be good for their prostate health. I'm kind of skeptical of that assertion. And so I would like to see, let me give you a minute or two, discuss with your neighbor and see what stories you can come up with that would generate this correlation without the causal effect being true, right? Assume that there is no effect if you have more, if you force yourself to go out and have more female sexual partners, it's not going to have any causal effect on your prostate health. And yet, that correlation can still be true. Okay, everybody got the assignment? Take a minute, see if you can come up with a story for why this might happen. What's going on?
I was gonna take a shot at hiding.
Oh, yes, please.
Could you break my wall?
Oh, yeah.
Oh, am I in the Zoom window instead of the?
Try it.
I'm in the right place now.
See this.
Yep, that's good. Thank you.
Right. You got that correlation. You sort of out, but you're not, your body's not checking down. Correct. Could it be? I think it's about one. No, I think no false.
Make sure your wife knows how important this is.
Higher, mechanically, it'd be healthy to do this. I mean, what people are going to be. What? Oh, well, that I have enough.
I don't know. That's the.
What? If you don't have a prostate, zero. All people that have a prostate.
Okay, so you can wrap up in the next 15 to 30 seconds. Okay, let's wrap this up. Can anybody share with me a story they've come up with that might generate that correlation without the causal effect being true? Yes?
So I was thinking they're more likely to die from sexual diseases. Therefore.
I see. So you think the data is there's a sample selection problem, that the people who were most promiscuous have died. Not from breast. Possible. I'm not sure I can quite get the correlation out of that. How do I? If I drop all the most promiscuous people, but then I still retain the kind of moderately promiscuous, I'm not even sure I see it quite how to get the correlation there. Anybody have a different story?
Another third source where the guys who are managing to have that much sex may be more attractive and a little healthier overall than the guys who are not having sex. Now there's an assumption that attractive guys get more sex. Or richer.
How could that possibly be true? I have not. Right.
Right. Subset of the population.
Right, exactly. So omitted variable here is kind of health status. People who have kind of more robust health, either good genes or they exercise a lot or whatever. On multiple dimensions of health, they're doing better, and this also gives them more sexual opportunities. And so that's where the correlation came from. some third thing was actually causing both of those things to change. Anybody come up with a different story?
Be simply that these men have more sex, but if you compare it to another group of men who have sex with just their wife, but they have it all the time, it could be that they have the same outcome. Therefore, it has nothing to do with the number of women, it has to do with the time you have sex.
Right, the cleaning out the pipes theory of prostate cancer. That all really matters is how many ejaculations you have, and it doesn't actually matter how many partners you have, but it's correlated with the number of partners, so we're picking up that correlation. Yes, that could also be true. It could also potentially be something like maybe high estrogen levels are bad for men's prostate, and they also turn out to be bad for men's sex drives, right? So you can come up with a bunch of potential mechanisms that could generate these correlated data, but the causality is just not there. Okay, so to me, like this is the most important slide of my presentation. To me, there is just a huge difference between observational data, which is what people did naturally, and experimental data, which is what happens whenever the researcher does a deliberate intervention. Here I'm imagining changing the price of a product to see whether the demand goes down when you raise the price, for example. But the point is that you're doing an intervention not because you think it's the right policy and you know that this is optimal. It's because you don't know what the truth is and you want to find out, and so you try something in order to find out what's true. So if Nicolas Cage wanted to know whether he was killing people by taking on so many movie projects, he could do a randomized experiment. Every time he gets offered a position in a movie, he could flip a coin and decide whether to accept or reject it based on the coin flip toss. Then he might generate enough exogenous variation in his data to be able to tell whether he's causing drownings to happen. I have reached the conclusion that we humans are really bad intrinsically at doing causal inference. And I've seen this from the, oops, what am I going here? I've seen this both when I evaluate research that's been done academically, and also, man, when I've worked in companies over the past 19 years, people get very confused about this kind of thing. When you want to believe that one thing when you got a theory that one thing causes another, people are willing to take extremely weak data and run with it and say, oh, we've just proven this causal effect that we were interested in. So I've told you my stories about the pirates and the presidents. But I want to tell you one more story from my own life to illustrate this. Oh yeah, I also notice this in sports, right? It's not just in my work that I've noticed. I think about baseball players who refuse to change their socks when they're on a hitting streak, and I think about all the examples that I've seen both in companies and in academic journals. And I have an evolutionary theory, evolutionary psychology theory for why we are so bad at causal inference. So the idea is that not just our physical attributes, but also our mental attributes may be shaped by evolution. And so suppose I see tiger poop on the ground and I think, gosh, the last time I saw that stuff, Fred got eaten, I better get the heck out of here. My genes might survive and propagate to the next generation at a much higher rate than if I don't make that notice. But suppose I'm having a terrible drought and I'm worried about feeding my family, and then I happen to move my hips and immediately hear a thunderclap and rain starts to pour. I think, oh, there's a pattern. Maybe if I dance, I can get rain to fall whenever I need it. And it doesn't work every single time, but sometimes it seems to work. And even if it's not causing anything, I'm probably also not wasting that many calories with my little extra dances. So there may be asymmetric reinforcement that causes it to be really important that we notice a pattern that we assume it to be causal and act on it. And we don't get hurt that much if we sort of do it too often. So we have lots of type 1 error in the world. Lots of false positives. So the key thing I learned in graduate school is that I need to be very careful about inferring causality from observational data. What matters is not the quantity of data. And so when I moved to Yahoo and everybody was talking about big data, I thought, having lots and lots of data is still not good enough. You have to have the right kind of data. The quality of data has to be high. So at this point in my dissertation, I decided to start from scratch. I had to chuck the 2 years of work that I had just done. And a light bulb went on for me that maybe I could find some way to generate my own data in order to answer a question that I was interested in. And so now it's 1994, and Amazon and Google and eBay haven't been invented yet. And a friend of mine from college was involved in inventing a game called Magic the Gathering. Anybody know this game here? It's produced locally, or at least in Seattle. And my friend, so if you haven't heard of Magic, you've probably heard of the Pokemon trading card game. Magic the Gathering was the very first collectible trading card game, and Pokemon has descended from it. And the amazing innovation they made with Magic the Gathering was they wrote some of the rules on the cards. And so then when they published new cards, it would change the rules of the game. And they sold these cards in random assortments like baseball cards, with some of the cards being more rare than others. And my friend pointed out to me the very interesting fact that the highest volume message board on the entire internet in 1994 was the one devoted to the trading of Magic the Gathering cards. Because the same sorts of nerds who were playing Magic the Gathering were also the people using the internet before the World Wide Web had been invented. And I thought this was pretty interesting. And people were at first just trading one card for another, but they quickly realized that cash is a useful medium of exchange. They wanted, I've got 60 cards I want to unload, I want to sell them, but I'm not quite sure what price I should be charging. So they started running auctions. And I was really fascinated by this. Now, I'd previously thought that auction theory sounded like an awfully boring area of economics, but now that I saw people running auctions for like $5 items, I got super interested because the internet was making auctions possible, bringing bidders together across time and space. And I thought, well, maybe I could use this marketplace as a laboratory to do experimental tests of auction theory. So I studied up on auction theory, and then I spent my graduate student housing stipend on Magic the Gathering cards so that I could then resell them in matched pairs in controlled experiments. And the first question that I attacked now that I was studying auction theory was, which auction format raises more revenue? And the first format that I tried was an ascending bid. Well, one famous auction format is the ascending bid auction. Another one is the sealed bid auction, where nobody gets to find out what anybody else is bidding until the end of the auction. And a third is the Dutch auction. This is a pretty cool picture. This is a flower market in the Netherlands. These huge pallets are tulips and other fresh flowers that are being bought and sent all around the world. And up here you have 3 different price clocks being done, conducting the auctions. And then here you have all the bidders sitting at all these desks, and each of them has a button in front of them. And the way this works is say, well, all right, this lot of flowers, we're going to start at 100 euros, 90 euros, 80 euros, 70 euros. Somebody finally hits the button, bam, stops the clock at 66 euros. That's the price being charged. So I ended up, my favorite thing that came out of my dissertation was the comparison of the sealed bid auction to the Dutch auction. I had 2 identical cards that I auctioned off in different weeks, and I sold one of them with a sealed bid auction, one with a Dutch auction. And then I repeated this dozens of times. And I also, in case the timing of the auction mattered, you know, in case the market was supporting higher prices one week than another, I did half of the cards with the Dutch auction first and the sealed bid auction second, and the other half flipped it so that I was controlling for the time period as well. And I got an interesting result, which is that I earned 30% more revenue with the Dutch auction. It was not predicted. The prediction of Vickery's auction theory is that these 2 auction mechanisms are strategically equivalent and they ought to give you the same revenue on average. But I saw this systematic difference, and that led to some more research on slow Dutch auctions, because instead of doing the 100, 90, 80. I was lowering my prices discreetly once per day, posting them into the news group, into the message board, and then allowing people to email me that they wanted to bid. Prior to my work, people had studied the difference in revenue between different auction formats using observational data, in particular US Forest Service data, because when they sell the right to log timber on public land, they did it by auction, and it turned out that so they made a comparison because the Forest Service actually ran two different kinds of auctions. They ran ascending bid auctions for some lots of timber, and they ran sealed bid auctions for other lots of timber. So they were able to conclude, this auction format raises more revenue than that auction format. Except that it turned out that the high quality timber was auctioned off with sealed bid auctions, and the low quality timber was generally auctioned off with ascending bid auctions. So it looks at first like it's all wood, but really it's apples and oranges. Because there was the data generating process had different qualities of wood being sold by the different mechanisms, we can't actually conclude that the mechanism was what was causing the changes in price. But with my experimental auctions, I was controlling everything. Right? I had exactly the same good both ways. And so there couldn't have been anything else causing the difference in prices. I didn't realize at the time how goofy everybody thought I was for doing this kind of work. Economics was observational science. Nobody was doing these kinds of real-world experiments. And so all of my classmates and most of my professors thought I was just playing some silly game with these stupid cards. But I was so convinced that I was doing something scientifically important that I did not notice until 10 years later when two of my friends said to me, gosh, David, you must feel really vindicated now that so many economists have started running field experiments. Only then did I fully realize how goofy everybody thought I'd been back in graduate school. Fortunately, I didn't starve. I spent about $10,000 on Magic the Gathering cards while I was in graduate school. And today, I recently did an estimate of what my leftover cards are worth, and something like $500,000. Pretty good, huh? But in some sense, that's peanuts. The Nobel laureate Richard Thaler was visiting MIT and first got to know me while I was working on my auction experiments. He wasn't a Nobel laureate yet, but he would be one day. And after I finished, he said to me after I graduated, well, David, you did get a really nice dissertation out of that project, but you could have started eBay. He's right, but who wants to be a billionaire? So now I want to talk about my favorite experiment that I got to do while I was at Yahoo Research. This is joint work with Randall Lewis, and it's Does Retail Advertising Work? So I abandoned my work on advertising in 1994. I went and did a bunch of experiments on auctions and charitable fundraising. And then in 2007, I got a call from Preston McAfee, who said, David, I have decided to leave Caltech in order to become head of economics research at Yahoo, and I would love for you to come work for me. And I thought, I can't imagine wanting to go to work for Yahoo full time for the rest of my career. I mean, I went to graduate school because I really wanted to teach college students, and now I have tenure. This is, why would I want to leave that? But on the other hand, I thought I'm supposed to be an industrial organization economist who knows something about how firms and consumers interact, and I have never been inside a firm. So I decided to take a year's leave of absence and go to Yahoo. And there I found that I was actually able to do experimental work to measure the effects of advertising. So I got to come back to my original topic. And then while I was on leave at Yahoo, I met my wife. And I ended up resigning the tenured professorship I had spent my whole life trying to get in order to stay at Yahoo. And so that's how I became an industry research scientist. So in this article published in Quantitative Marketing and Economics, we worked with an American retailer and found economically large effects of online ads. The retailer is one that keeps very careful records on its customers. They think that they are able to correctly measure more than 90% of their in-store purchases and attribute to the correct individual customer. For example, if I go in and make a purchase at this retailer, they'll say, we recognize this credit card. This is the same David Reiley who was in here 8 weeks ago. Let's put this under his record in our CRM system. And if I don't use a credit card, they'll ask for my phone number and try to link my purchase to that account. So we found 1.6 million customers who matched by name and address, either physical address or email address, between the databases of the retailer and Yahoo. We assigned 80% of our matched consumers to the treatment group for the ad campaign, and they were targeted with retail image ad campaign for this retailer. And 20% were assigned to the control group, and they don't see the retailer ads. They were not targeted with any ads. And these ad campaigns were called run of network on Yahoo, so they could have been on the Yahoo homepage and Yahoo Mail and Yahoo News, Yahoo Autos, anywhere, any place that Yahoo was showing ads to consumers. Following the online ad campaigns, we got both online and in-store sales data for each week for each person. We worked with a third party to match the data for us and then de-identify it so that we didn't know in the final data set who was whom. And the retailer decided they didn't want us to know what the actual dollar amounts were, so they picked a scaler to multiply all their dollar amounts so that we wouldn't know what it was. Randall and I each came up with a different way to reverse engineer their scaling factor, and so we do know exactly how much they are, but out of respect for the retailer, I'm not telling you exactly what the scaling factor is. My favorite nickname I was ever given was when I went to present to this retailer, and the head of the marketing team that had worked on this experiment with us started calling me the mad scientist because we had figured out how to reverse engineer that number. So first we do descriptive statistics for the first campaign we ran, and it shows us valid treatment control randomization. This is the first thing I do every time I run a field experiment. Can I show that the treatment group and the control group look the same as each other on all characteristics prior to the experiment? And so here we see 59.5% are female in each group. 76.4% of each group got at least one Yahoo page view during that period. So already you can see that 24% of people are not going to be able to get any ads because they didn't even use Yahoo during the period. We had an average of 360 page views per person on Yahoo. Now the retailer ad views, so this is what's now frequently called the compliance rate. We got 64% of the treatment group to actually see the ads, and then the other 36% kind of didn't browse Yahoo enough to get any ads, or other advertisers were targeting them more or something. There was some reason that they didn't get ads. We had 25 ad views per person on average, including all the people who didn't get any ads. There was a 0.3% click-through rate, which is quite high. Most click-through rates were for ad campaigns during this period were less than 0.1% of impressions were clicked, and 7% of customers clicked at least one ad during the campaign. And the experimental differences show us a positive increase in sales due to ads. The control group bought $1.84. The treatment group bought $1.89, so kind of a 5-cent difference. And the problem is 95% confidence interval for that difference is 5 cents plus or minus 7 cents, right? Because you can see this standard error of 3 cents and this standard error of 2 cents. When we combine them together, we've got plus or minus 7 cents for a 95% confidence interval. So not super strong evidence that the ads had a positive effect. But if this effect were true, if 5 cents were definitely true, it would have been a very profitable campaign for the advertising. Now, this is the important thing that I've been trying to do over and over to teach people how badly we can mislead ourselves with observational data. If we didn't have an experiment, then we would have no control group, right? The advertiser would just try to advertise to everybody on their mailing list. And there we would see that if you were exposed, so out of the treatment group, 64% of them were exposed to the ads. and 36% were not exposed to the ads. These 64% had an average purchase amount of $1.81, and these folks had an average purchase amount of $2.04. Things are going in the wrong direction. We would conclude that the ads decreased sales by 23 cents. And okay, I mean, I guess maybe you could be annoying people so much with your ads that they start boycotting your store, but we know from the experiment that can't be true. They were pretty close to each other when we look at the randomized treatment versus control group. We know that the treatment group and the control group are identical to each other. We don't know that the people who got exposed were identical to the people who didn't get exposed. So that's how badly we can screw up, and we get a treatment effect that is more than 3 times as large and with the wrong sign. So we look next at the pre-campaign data. And this emphasizes that the non-experimental sales differences have no causal relationship to the ad exposures. How do we see this? Well, before the ad campaign happened, the people who were going to get ads next week were buying $1.81. The people who were going not to get ads next week were buying $2.15. So unless you think that the causal effects work backward in time and that, you know, seeing ads in the future is causing you to buy less now, we can see that this is really a selection effect. That the kind of person who gets exposed to the ads in the ad campaign is somebody who tends to buy less from this retailer, and the kind of person who on this list was not getting ads from the ad campaign tends to be someone who buys a bit more. So we can solve this mistake with our experiment. The ad exposure appears to have prevented what would have normally been a decline in sales during this period. So the control group starts at $1.95, goes down to $1.84. The treatment group, well, the exposed part of the treatment group goes from $1.81 to $1.81. It stays the same, but the unexposed group goes from $2.15 to $2.04. So the control group is going down by 10 cents. The unexposed part of the treatment group is also going down by 10 cents. And the unexposed part of the treatment group is also going down by 10 cents, but the exposed part is not going down. Yes, Zoe.
The ones who aren't exposed are just those who didn't open Yahoo. It seems like
there's more than that. So it was 76.4% of people browsed at least one Yahoo page in the treatment group. Another 10% browsed Yahoo, but kind of not enough to get this ad campaign, right? There were lots of advertising campaigns being served, and so you had to browse enough pages, and you had to be not in too much demand by other advertisers who were buying up all of the ad impressions for you. So treated group sales stayed constant while the 2 unexposed groups had their sales fall. Well, that's kind of interesting. So we then do a difference in difference estimator to get a statistically and economically significant treatment effect. Now we have the estimated effect per customer is 10 cents on the treated individuals, right? So this 5 cents difference we saw before is kind of an intent to treat thing. This is the average treatment effect on everybody, including the 36% who never got any ads, who could not possibly have been affected by them because they didn't get them. But when we do the effect, a difference in difference estimator to estimate the treatment effect on the treated, now we get 10 cents and a standard error of only 4 cents. So that's statistically significant, still just kind of barely. And the estimated treatment effect, the sales impact for the retailer is 83,000 of these fake dollars, plus or minus 70,000. That's based on 800,000 people being treated, and we compare that with the cost of the ads. So this is where I needed to know what their scaling factor was, because I wanted to know what was the actual cost that they spent. So I've transformed the actual dollar amount I knew into their fake dollars using their scaling factor. And so they're getting $83,000 for a cost of $25,000. That's a 325% increase in revenue compared to cost. We think this retailer has markups of about 50%. And so this should be a very profitable campaign if that estimate is true. Of course, we've estimated with a lot of uncertainty. And folks were very surprised whenever I first did this experiment, you know, what is it now? More than 15 years ago. And I said, you know, it's very hard to show statistically significant effects of the advertising. And some of my academic colleagues said, oh, well, that must mean that the effect is zero, because everybody knows that if you have 1 million observations, everything is significant in a regression. But that's because of specification error. That's because every time we write down an observational regression, we make arbitrary decisions like, oh, this is linear, or these are the variables that are included, and I don't have any of the unobservables, but that's okay, because I'm willing to assume that they don't have any effect, or that their effect is uncorrelated with all my variables. But here I don't have any specification error. All I'm doing is asking, what is the average purchase amount for the people who got the ads? What's the average purchase amount of the people who randomly didn't get the ads? And then any difference must be due to the ads. It's not like you're going to automatically get something statistically significant just because you have a lot of data. If there's nothing there, then you won't get anything in terms of statistical significance. So I thought it was very interesting that our point estimate said this is a profitable ad campaign. We just can't measure it with much precision. And it turned out this is a very important problem in advertising, that it is very hard to measure the effect on final outcomes because we're generally explaining only a very small fraction of the variance. We're explaining like 0.1% of the variance in sales with this ad campaign. Okay, any questions on that one before I go on to my Pandora study? Yes?
You decide the time frame purchases. Because couldn't advertising have a longer term effect in the sense that
Oh, yeah.
ads and you didn't buy this week, but 2 months later.
Yeah, I didn't.
I wanted that, but I didn't feel like I quite had the money at the time. I don't know.
Because I have limited time, I didn't include all the slides. We did think about that. So what happened was we had 3 different ad campaigns that we did with the same randomization, and they took place over this like 2-month period. And so there were like, we did the first ad campaign, then we looked at what the treatment effect was, then we looked at the second ad campaign, what was the cumulative treatment effect of those 2 ad campaigns, and then what was the effect after the third ad campaign. And the treatment effects got bigger and bigger as we did that.
So there was a cumulative effect.
So there seemed like there was some cumulative effect. On the other hand, as we kind of went farther out, the variance also sort of went up. And so it still was very hard to say that it was a statistically significant difference, but we saw positive treatment effects for each of the 3 ad campaigns, and it seemed like there was some cumulative effect of doing that. Of course, when we were doing it with the difference in difference estimator, one thing that could have been wrong is that the pre-period, it could have been a fluke that one group was buying a little more than the other, but that fluke got magnified every single time we looked at something in the future. So I'm not super happy with that part of it. But even if you just look at the pure randomized experimental results, I did the difference in difference estimator in hopes of getting statistical significance. But if you just look at the regular experimental results, we were getting positive treatment effects all the time. They just weren't statistically significant. Any other questions? Yes.
What should take away from that? If you're consistently finding a positive effect, but it's never statistically significant,
What should you believe?
should I be concluding that it has a positive effect, but we're looking at such a small portion that it's never going to be statistically significant? Should I conclude that because it's statistically insignificant, that there doesn't really seem to be an effect of the ad campaign? I understand Yahoo had a vested interest. Which one of those are
Right.
right?
So the way I think about it is the point estimate is the best estimate we have. And because that point estimate was profitable, I was inclined to think, okay, well, our best estimate is that this was a profitable ad campaign. We're just super uncertain about it. And I'm not willing to say because it's statistically significant, it must be 0. That doesn't make sense. The best estimate we have is the point estimate. It's just we're super uncertain about what the actual effect is. So we have low statistical power, even though I have 1.6 million observations. So we worked on other ways to increase our statistical power as we continued over time to work on things like this. And so one thing that we learned to do, one thing we were able to do was argue to the advertisers, hey, give me a 50% treatment group instead of just a 20% treatment group. That allocates the data more efficiently. If you get half in treatment and half in control, that gives you smaller confidence intervals than if you have a lopsided randomization. The other thing that we learned to do was placebo ad designs. So if we could run American Red Cross ads to the control group and book the campaign in exactly the same way as we were booking the retailer campaign, then the people who got the Red Cross ad in the control group would be the people who would have gotten the, let's say, Neiman Marcus ad in the treatment group. What's so useful about that when you have noncompliance is that now I can throw away all the people who weren't treated. What some people have been, I just, let me see. I just saw a talk by the folks who got really who did in political science what I was working on doing in economics, and they were looking back on 25 years of political science experiments, and they said, before we came along, there actually were some very early field experiments in political science. Folks did a get out the vote campaign where they randomized which doors they knocked on, and then used public records about who had voted to evaluate how effective is it to knock on people's doors to encourage them to vote. Do people in the treatment group vote at higher rates than people in the control group? The answer was yes. But the folks who had done the earliest experiments back in the 1950s had said, well, gosh, we don't want to throw away any data. And so when we knocked on a treatment group door and nobody answered, we go, okay, well, that person didn't get treated. Let's throw them into the control group. Not cool. Not cool, right? That's like saying, I'm going to take these people who didn't get exposed to the retailer's ads, and I'm going to add them into the average with these people in the control group. But we can see these people are totally different from these people in terms of how much they're purchasing from the store, right? We should not be pulling them together. There is something different about the folks who got the ads than from the folks who didn't get the ads in the sort of the natural observational way. And we don't want to mess up the beautiful experiment we've done by throwing people from the treatment group into the control group, because they're different. So we realized early that we didn't want to do that. But if we played placebo ads for the control group, then we could throw away everybody who never got any ads either in treatment or control. Now I'm just going to look at that 64% of data, and I shrink my confidence intervals a lot because I'm throwing away a lot of noise and I'm not throwing away any signal.
Would that make really useful? I mean, I get why you don't want to throw them into the control group. They're not going to, because there's something endogenous now about them. They didn't
Right.
open the door,
Right.
That's the data point. But wouldn't that make a lot more effective control group, like the intent to treat group versus the treated group? You could still don't put them in the whole control group, but have them as a separate control group. Like we tried to treat them.
So I mean,
in case your randomization was bad or you didn't do your control treatment very well, would there be use in that still?
Okay, so a way to do it that I know is correct is take everybody in the treatment group, whether they got treated or not, compare them to everybody in the control group, nobody in the control group got treated, right? And then figure out what's your intent to treat estimate. And then if you want, you can divide by 0.64 the contact rate and see what the total effect on the treated is. So what you're suggesting to do with the untreated folks is
just treating that as, ignore the control group. Like, so you have this, randomly decide this group's going to get treated, but half of them don't knock on their doors. Is that completely useless because they've signaled something by not knocking on the door?
Right.
That you would want to confound for it.
Right.
Okay.
Anybody who didn't answer the door is different from the people who did. The people who didn't answer the door, we can see that they have different voting rates than the people who didn't. The people who did answer the door. Okay. Any other questions before I move on to Pandora? Great. So this study is about. I like to call it the best demand curve ever estimated. And here, instead of just a measly 1.6 million people in my experiment, I have over 30 million people in this experiment. And the question is measuring consumer sensitivity to ad load. And it's a long run experiment instead of just the few weeks that we were doing with the ad effectiveness study. This is going to be a 2-year study. So how sensitive are listeners to the quantity of audio advertising? And this is a key question for Pandora to know the answer to. And if we consider the number of ads per hour, that somebody receives to be the price of listening to ad-supported Pandora, then what we're doing is estimating a demand curve. We're going to vary this price across listeners, keeping consistent treatment assignment for 20 months until we finally saw the treatment effects stop getting bigger. And then we ended the experiment. This experiment ran from 2014 to 2016. And we had experimental variation only on mobile device listening. If you were listening on your iPhone or your iPad or your Android, you were enrolled in the experiment. If you listened on web or with smart speakers, then you weren't in the study. But it was about 80% of total listening hours were on the mobile devices. And we had over 1 million listeners per treatment group, where each group is 1% of Pandora's listeners randomly chosen. And we include everyone who listens at all to ad-supported Pandora during the treatment period. We decided on a 3x3 experimental design where we independently vary how many ads per pod, where a pod is a commercial break, and how many pods per hour. So the default at the time was 1.5 ads per pod, 4 pods per hour. That is, we set a timer for 15 minutes at the end of your last ad. We let you listen to music for 15 minutes, and then after the timer expires, when your next song ends, then we put in another ad break. So it's not really 15 minutes between pods, it's a 15-minute timer that gets set, and then how many ads per hour you get sort of depends on how long are the songs you're listening to. And when I say it's 1.5 ads per pod, we would start with 1 ad in the first pod, 2 ads in the next one, 1 in the third, 2 in the fourth, and so on. So it's an average of 1.5 per pod. So we varied it 1, 1.5, 2, 3, 4, 6 pods per hour that we could have scheduled. First, we do a randomization check, like I said before. Let's check what do the groups look like in the month before the experiment. And we see I've normalized a lot of these variables because Pandora didn't want me to reveal actual amounts. So if the control group was listening to 100 hours, then the lowest ad load group was listening to 100.04, and the highest ad load group was also listening to 100.04. You can see total days active is equivalent, total audio ads, total audio pods in the entire month, total ad capacity, percent of users who were paid subscribers. So paid subscribers are not supposed to be seeing ads. What's going on here? Well, this tells us that in the month before the ad campaign, 1% of the people that I ended up studying who ever listened at all during those 20 months, 1% of them were paid subscribers at the beginning. So at some point, their paid subscription lapsed and they started hearing ads. So it's same percentage across groups. 46.7% male, or 46.6, I guess, percent male. Here, the control group was actually a 10% group, so it had 18 million people in it. And then each of the individual groups had 1.8 million in them. And so chi-squared tests failed to reject the equality of the variables across all 10 treatment groups that we had. I'm only showing you 3 treatment groups here, but there were 10 of them. We verify that the ad load does vary over the 20 months of treatment. So in the control group, total audio ads per hour was 3.6 over that 20-month period. In the lowest ad load group, it was 2.7. And you can see these standard errors are super small, so this is a big difference statistically. And then in the highest ad load group, we have 5. We have 5 ads per hour. How many ad pods per hour? 3 in the control, 2.6 in the lowest group, 3.5 in the highest group. Ad capacity per hour, we don't fill every single slot, it turns out. Most advertising publishers online fill every slot by using an auction, but we did not have that. We had forward contracts that the advertisers agreed to, so sometimes we would have an empty ad slot. So the ad capacity went down in the low ad group, up in the high ad group. Percent of non-zero pods was 93.4, 93.2, 93.5. So even these were a little bit different. Audio ads per pod was 1 in the lowest group, 1.3 in the control group, 1.4 in the highest group. And So we see clear evidence of treatment effects this was showing you the X variables. Now here's the Y variable. Total hours listened to two different Y variables. Total hours listened 1.7% higher in the lowest group than in the control group, and almost 3% lower in the highest ad load group than the control group. So we are affecting listening hours by playing people more ads. And number of days active was 1.6% higher in the lowest group, 2.6% lower in the highest group. We're measuring outcomes now in the 20th month of the experiment. So after they have had almost 2 years of exposure to the treatment. And as expected, we see less consumption. The demand curve seems to be downward sloping. Now, remember, we don't have full control over ad delivery. We're able to change these timers, and we're able to change how many ads per pod. The highest treatment group could, in principle, have had 12 ads per hour. 6 pods per hour, 2 ads per pod. But the actual ad load is a lot lower than that for 3 reasons. You can see the actual distribution here goes from 0 ads per hour up to, there's where 12 would be. Almost nobody is getting 12 ads per hour. Lots of people are getting, even this highest treatment group, lots of people are getting 3 or 4 ads per hour. Yes, Zoe. Wait a minute. That is a super important question. That is including the ads. So it's total hours that they are spending listening to Pandora. Some people argued for doing just the music time, but I was afraid that that was going to cause a mechanical change. What I really wanted to know behaviorally is how much time did you spend listening to Pandora? So that's what we're trying to do, total ads plus pods. And it wasn't easy. We had to do a bunch of data engineering to get that, because what we had usually measured was music time. Was there another question? No, okay. Oh, right. The actual ad load is lower than this for 3 different reasons. We have variation only on mobile devices, so you're not going to see somebody listens only on web, they're not going to get any difference in treatment, but I have to include them in my experiment because I don't know. For the same reason that I had to include all the unexposed people in the Yahoo experiment, I need to include everybody, whether they're actually getting serious treatment or not, because it's too hard for me to know for sure. I guess I could have thrown out anybody who only listened on web, but that's not what we chose to do, and it's not. Almost everybody ends up listening on mobile at some point. We don't sell every single impression, so some people get blanks, and also ads wait till the end of a song, so it depends on what songs you're listening to. So what we're going to do is an instrumental variables regression for the actual ad load using experimental treatment dummies. If that is something you have not learned about in econometrics class yet, don't worry. I'm going to explain intuitively how this is going to work. Here is our demand curve estimate. This is my favorite graph I've ever generated in my career. Here we see on the horizontal axis how much mean realized ad load did you have during that 20-month period. How many ads per hour did you get? Here's 3, here's 5, here's 5.5 at the average ad load for the people who are in the highest ad load treatment, the 6x2 treatment. And this is the control. That was the default before we started the experiment. And it's really cool. They all lie almost on the same straight line. Downward sloping demand curve, and it's surprisingly linear. This is so the way the instrumental variable estimator works is you're putting in y, which is mean total hours. 100 is the normalized control value. We're putting in each person's listening in the final month of the experiment on the left-hand side of the regression. On the right-hand side of the regression, we put how many ads per hour did they get over the course of the experiment, but we don't want to use any of this dirty variation. Any of this variation depends on people's behavior. They're listening to longer songs. They're listening on web rather than mobile. All the things that they're doing differently. Some advertisers really like advertising to me, but they don't really like advertising to you, so I have a higher ad load. All of those things were not random, and so I cannot trust them. So I'm throwing away all of this variation. the within treatment group variation. I'm only keeping the between treatment group variation. How does that work? Well, I'm regressing this y on this x, but I'm instrumenting for this x using my 10 treatment dummies. Okay, that is numerically equivalent, but numerically equivalent to just plotting this graph, saying what's my mean x and what's my mean y in this group, what's my mean x and y in this group, and so on, and then I run a regression through these 10 data points. And that tells me what is the slope of this demand curve. The cool thing about doing the instrumental variables version of that regression is that it gives me accurate standard errors. So I know how precisely have I measured the slope of this line. So here's how precisely we measured it. The slope of that line is minus 2.07. So for every additional ad per hour, we get 2.07% less listening. And we've got a standard error of 0.12. So I've got a t-statistic of more than 10. This is a really nice, precise confidence interval, 2.07 plus or minus 0.25 is a 95% confidence interval. Here's my other y variable. How many days did you listen to Pandora? And here we get minus 1.9% fewer days, 1.9% fewer days for every additional ad per hour that you got on Pandora from the exogenous experiment. Then we looked at heterogeneity and treatment effects. Are some of our listeners more sensitive than others? And the main variables that we looked at were ones that matter a lot to radio advertising buyers historically. So they had these 4 different age groups that they were interested in: 13 to 17-year-olds, 18 to 24, 25 to 54, and 55 plus. And we also looked at gender, male or female. The gender, I ended up with 4 lines on this page. Basically, these are the 25 to 54-year-olds. If I plotted males and females, they both looked pretty much identical. So I got rid of the gender thing and just looked at the ages. So the youngest people are down here at the bottom. The next youngest, let's see, the youngest people are this solid line at the bottom. The 18 to 24-year-olds are up here. The 25 to 54-year-olds are up here. And the 55 plus, the group that I've just aged into recently, are down here close to the teenagers. But what we see is that the levels of listening are different across age groups, but the slopes are just about the same. So there's not a whole lot of heterogeneity in how much listening we lose from people as a result of playing them ads. So now let's decompose the effects of this ad load treatment into intensive versus extensive margins. I hate these words. I think they're unnecessarily jargony, but what I mean by it is we can look at how many hours they listened during that month. We can also look at how many hours they listened per day they listened that month. We can also look at how many days they listened, conditional on being active, and then we can also look at whether they were active or not. So there's kind of 3 different levels of intensity that we can look at here. This is the total. This is how many hours per day. This is how many days per active listener, and this is how much did you get as a result, how much change did you get in the fraction of active listeners, right? So we're losing like a little less than 1% of listeners are active at all during that month per additional ad per hour. We're losing like 1% on a little less than 1% on how many days you listened, and we're losing like a little less than 0.5% on hours per active day. If I try to normalize and figure out what fraction of contributions made by each of these things, it's basically 40% of the effect is listeners stop listening. 45% of the effect is listeners listen fewer days in that last month, and 15% is they listen fewer hours per active day. Now, why did I run this experiment for so long? Well, it's because the treatment effects kept increasing gradually. So here's my control baseline, and then relative to control, what does the lowest ad load treatment look like, and what does the highest ad load treatment look like? And you can see that the highest ad load group is lowering their listening hours, and they're still lowering it. And well, we got a big bump up here, but overall it's still going down, and it's still going down for over a year. and then it finally flattened out. Same thing with the lowest ad load group. So I wanted to know if we permanently changed the ad load, what would be the effect in the long run? So that's why I wanted to run it this long until we saw the treatment effects flatten out. And the effects on unique listeners grow even more slowly than the effects on hours, which was a little surprising to me. So you know, from this, we probably could have cut off the experiment here, and I would have said, oh yeah, we're done. But I was also looking at this graph, what's the fraction of people who are still listening, and that kept going down over time. So we finally said, all right, this looks kind of flat enough. We can stop the experiment here. If we had stopped the experiment early, which most tech companies do, it is almost unheard of to run a 2-year experiment in a tech company. People want to run an experiment for a week or a month, find out the answer, move on. And I was like, I don't think we can afford to do that if we actually want to know the answer to this question. So I'm very happy that Pandora let me run this experiment for so long when most people are too impatient for that. If we had stopped the experiment earlier, we would have vastly underestimated people's sensitivity to ads. So here I'm doing things in terms of demand elasticities. If we had stopped the experiment in the first month, we would have said, oh, the demand elasticity is 0.025. But actually, by the end, we knew that the demand elasticity was 0.075. So we've been underestimated by a factor of 3. Now, let me do the same trick that I did with the Yahoo study. Suppose I didn't have the ability to do an experiment, and I want to know what's going on, you know, if I had the observational data available to me, what's the best causal effect I could have measured. So let's restrict attention this time to the control group. We had lots of dirty variation in each group, right? There's lots of variation in how many ads per hour you got, even though you're in the same treatment group, because of things that are due to your behavior. And we'll try a simple regression of listening hours on cross-sectional variation and ad load across consumers. So for each, so I'm going to make a table, and each one of them I'm going to say, here's how much each person listened within the control group, and here's how many ads per hour they got. And I'm going to see what does it look like if I regress one on the other. And I get not 2, but 9. Right? We know the truth is 2.07. What I would have gotten by doing a simple-minded regression of listening hours on ads per hour is that, wow, this is a really, you know, people are stopping listening at a pretty high rate. Active days, instead of 1.9, I get 6.8. So we're overestimating actual listener sensitivity by a factor of 3 to 5. And the listeners who are in higher demand by advertisers, this is the way I look at it, listeners who are in higher demand by advertisers, they get more of their ad slots filled, let's say, and so that gives us a spurious correlation, that these people who are in higher demand tend to be lighter listeners, right? The kind of person who advertisers are trying to reach with more ads is also the kind of person within my data set who is listening fewer hours to begin with. Okay, but that's not the most sophisticated thing we could do with observational data. We could use a panel estimator. We could look at the same people before and after and see what happens as a result of that. And that is going to help us estimate fixed effects for each listener, just like when you try to do a study of the returns to education. You can say, well, okay, it's probably not such a good idea to just regress income on years of education, but maybe we can look at people who are earning income before and after college, and we can say, well, you know, the problem with just doing the returns to education simple-minded regression is that you're going to vastly overestimate in some cases, because high-quality students get more education. They also would have gotten more income regardless of their education level, so you're going to over-attribute causal effects to education. But you could fix that with looking at people before and after. If ability is sort of held constant, then you can use a panel estimator. So we can do that here. But because treatment effects are growing slowly, without the experiment, we wouldn't have known what time scale to use. A week, a month, a year? The experiment helps us both for generating the data to help us measure causal effects, and also to help us figure out how long is long run. But let's just be as kind as we can to the observational data. and say, suppose God told us on a stone tablet that the right amount to watch is 2 years. That's how long it takes for somebody to adjust to a different ad load. So we give the panel estimators best shot by using these 20 months between observations. For each listener, we have 2 observations. One that is June 2014 listening and May 2014 ad load, and the other, so that's the beginning of the experiment, and then the other is April 2016 listening versus the ad load over the entire 20 months. And then we're going to ensure a balanced panel by dropping anybody who was not listening in May 2014. And the result for active days is not too bad. 1.9 is the truth. We get 2.3 here. Hey, that's pretty good. Maybe panel estimator will help. But now look at this one. It's supposed to be 2.07. I still get 6.6. The panel estimator is supposed to be a much better causal effect estimator. It still sucks. It's still, 3 times as large as what the actual truth is. And I couldn't figure out at first why this one was so bad and this one was kind of okay. And then I hired a young MIT PhD who came to work for me and said, oh, I think I know what's going on. Whenever we play ad campaigns on Pandora, we always invite the advertiser to specify a frequency cap. You don't want anybody hearing your ad more than once an hour. You don't want anybody hearing your ad more than 5 times in a day. So we put these parameters, the default parameters, as I recall from the time, were no more than 1 ad per hour, no more than 5 ads of the same kind per day, and no more than 15 of this ad per week. All right, well, given that we did that, what can happen is that for some people, we run out of ads to play if they listen too long in one day. So if somebody listens 13 hours in a day, we might run out of ad campaigns in hour 11. And so you get to listen for free for the last 3 hours of the day. It's causality. It's not that it's not so much that the ads per hour are causing people to listen less, it's that people who listen more get fewer ads per hour, right? And so that is where all of this comes from. Instead of getting a -2, we're getting a -6.6, because mostly, there's like 2/3 of this is reverse causality instead of actual causality. Oh, what time is it? Am I over time already? No, I've got 2 minutes. I can put in a little ad for the fact that I'm now becoming a theater artist. I'm doing what I did for the first half hour, and I'm expanding it to talk about all the experiments I've done in my personal life. Do we have enough time that you'd like me to do the last bit? Okay. Okay, very good. Uh-oh, I'm not hearing it. Maybe turn off. Oh, there we go. Hang on. All right, so for my class at Berkeley, it's an all-online class, and so I recorded all these video lectures, and I decided on a lark to write a parody of Sarah Bareilles' Brave that is all about the topics that we do in my class. So I'm going to perform that for you now. When a correlation seems to be amazing with its power to predict, we think that ice cream eating causes drownings from the data you depict. Or you can start thinking nothing's gonna trick you like the slick view of a convincing scatter plot. Centered air skin tight with no insight, your regression all for naught. I wonder what would happen if you run an experiment and let the truth fall out. Honestly, I wanna see what it says. An experiment to find causality. Honestly, let's see your treatment effects. Wanna see your, I just wanna see your treatment effects. I just wanna see your treatment effects. Oh my gosh, I forgot the second verse. Maybe I should stop. You can see the other verses on my YouTube. Any final questions? Yes, Zoe.
I'm not sure if you're familiar with it, but for my economics studying class I was teaching, we were talking about, price discrimination and pricing experiments. There was this recent Consumer Reports and Groundwork Collaborative, came out with this Instacart kind of report about how Instacart was doing dynamic pricing and was actually like showing people was giving people different prices at the same time, even on the app. And there was a lot of kind of consumer folks and advocates who were like upset about this. And so I'm curious about just like from the, and this was upsetting to some of the students as well, that people were facing different prices. Now you're showing people different prices, but I'm curious when you're thinking about.
Well, I was, if you think of number of ads per hour as a price.
Yeah, that's true. So I'm curious about like in the setting that you've been working in, when you're thinking about the ethics of these experiments or how consumers might react to knowing that they're in an experiment after the fact, or knowing that they could be experimenting as a user, like how do you think about that? And what might you have to say to folks who are concerned about that?
Right. So one issue is price discrimination. Are you charging different prices to different people based on who they are? Well, there's been some of that for a long time, right? Student discounts, senior citizen discounts, so on. Or look at airline pricing. There's lots of dimensions on which they discriminate. The question is it okay to randomize? So I'm not discriminating against anybody, but in practice, some people are having to pay different prices than others. In 97, I think, I remember reading an article about Amazon, maybe it was 98. Amazon had been experimenting with prices, and folks in an online message board had noticed that they were paying different prices for the same CD or the same DVD. And there was a lot of outcry about this. And Amazon made a statement that they said, okay, we were just randomizing prices in order to figure out what price we should be setting, but we get that people are very upset about this, and so we're committing never to do this again. And I thought, man, that is a bummer that they made that decision never to experiment, right? Because, ex ante, there's no discrimination. We're just randomizing. You might get unlucky and get a high price, but I think I've also thought about, are there other ways to get people more comfortable with it? Like, would it be more palatable to people if we said, congratulations, you've just been randomly selected for a 30% discount? Would people get mad about that? Probably not. I've been very keen to try that, but I haven't managed to persuade anybody to do it yet. What was the other part of what you said? I felt like I had another response to give you. Now I've forgotten what it was. Oh, ethics. Ethics. There is also a widespread attitude that folks don't like being experimented on. That you're treating me as less than human if you experiment on me. And my position on this has been, if we're telling you in good faith, this is the experience we're giving to you. It might not be the same as the experience we're giving to somebody else, but we're treating you with your respect. We're not lying to you about what we're giving you. We just want to see how do you react to this offer that we're giving you. I would like to think that is not unethical. I had significant disagreement 15 years ago when the Facebook emotional contagion experiment happened. So Facebook modified their algorithm to upweight posts that used words about sadness in them. And then as an outcome, they looked to see, do people write about being sad themselves more when they see more sad posts from their friends? And the answer was yes, we could measure that. People got really mad. How dare you? You might have caused somebody to kill themselves because you did this to them. And I'm just like, hey, these companies are constantly experimenting with their algorithms to try different things to see what's going to give a better customer experience. And it seems to be a terrible idea to jump down their throat because they actually publish the results of one of their articles. Would you rather they run all these experiments and never tell us what's going on? Because that's what you're incentivizing to do when you complain like this. But I often have a different point of view on ethics than other folks. Like if you do human subjects experiments, they make you take classes on how it's not just the evil Dr. Mengele and the terrible Tuskegee syphilis study where they let all these black men have syphilis progress without ever telling them that they could get treated because we wanted to know what would happen. Those are pretty bad, but it's not just the medical people who are evil, it's also social scientists can be terrible. Look at Stanley Milgram. Stanley Milgram brought undergraduate students into his lab at Yale, told them that they were going to be working on a memorization exercise. Half the students came into the lab with the professor, and the professor said, all right, you need to turn the dial to shock the kid in the other room whenever he makes a mistake. Turn it to 3. Turn it to 4. Turn it to 7. Silence. And some of the kids turned the dial all the way up to 8, 9, even after the person became unresponsive. And the argument is this was a very unethical experiment because it made people feel bad about themselves when they debriefed them afterwards and said, you know, we just wanted to know how much you were going to be willing to obey authority. And it's so unethical. How could you make somebody that uncomfortable about themselves? And I'm just like, screw that. If I'm the kind of person who would listen to authority so much that I would shock a fellow classmate into unconsciousness, I would like to know that about myself. Why do you think that I need to be protected from this knowledge about myself? I want to know so that I can do something about it. So I disagree a lot about what people say with experiments on human subjects. And so I may not be I'm certainly not representative. I've got my own beliefs on this. But last year there was an experiment done by people on Reddit where there's a subreddit called Change My Mind. So, you know, I come in, I describe some policy position I have or some ethical position I have, and I invite other Redditors to change my mind. And so these folks deployed an LLM to respond to these threads. Half of them got the LLM deployed to try to talk them out of their position, and half of them didn't. And folks were much more likely to change their mind whenever the LLM argued with them than when the LLM didn't argue with them. And then afterwards, this paper was about to get published, and the Reddit folks found out what had happened. They were like, this is horrible. This is so unethical. You never told us that you were doing this. And we were being treated, you know, so poorly because you didn't tell us that this wasn't we all assumed it was humans talking to us. And my position was, obviously people are going to deploy chatbots on online message boards now, and they're not always going to tell you. So to do something that is clearly going to happen and do it as an experiment so we can find out what the effects are, that seems to me pretty ethical. But I'm in the minority on this apparently, or at least I'm not among the people who are loudest. Okay, I've gone way over. Was there any other pressing question? Thanks so much for your attention.
Thank you.
Oh my gosh, what happened to my second verse? Ugh.
We'll hang out outside for a few minutes.
It's been too long since I rehearsed that one.